Alright, welcome on back, and I think that we should be able to finish up a review here pretty quick in this video part 2. Let's take a look at one where I told you that f of x was equal to 1 over x minus 3, and I said to make a table and then to graph the function. Well, let's sketch a graph of the function of this thing first. Hopefully you realize that there's a vertical asymptote at x equals 3 and that this is a hyperbola. So it's going to look like this. And it's going to have a y-intercept of negative 1/3, so it's going to look like that. So there's a sketch of our graph. Now in terms of an xy table, we can pick out numbers like, I don't know, negative 2, negative 1, 0, 1, 2, 3. And if we do this, negative 1/5, negative 1/4, negative 1/3, negative 1/2, negative 1. Oh, and look at this. Undefined, right? 3 minus 3 is 0, and that's undefined. And if I could do something like that, I'd be feeling pretty good about myself. Another one I might be wanting to do is if you were given a very nice exponential equation or expression, 3x to the 227th power over x to the 221st power is equal to 3 times x to the 6th power. Because when we have the same bases, we subtract the exponents when we divide. So 227 minus 221 is 6. Right? If we want to look at another one, let's say we had 5x to the 17th over 2x cubed. That's 5x to the 14th over 2. We just subtract the exponents. Now, let's say that we gave you something like 3x squared y to the 17th times 2x to the 15th y cubed. Now, when we multiply things like this, 3 times 2 is 6. The x squared times x to the 15th literally means that we have 17 x's that we're multiplying together. So we write that x to the 17th. Y to the 17th times y cubed is y to the 20th. Okay. We want to take a look at another one. Let's take a look at something like 4x to the 7th, y to the 4th, times negative 3, x to the 5th, y to the 5th. Let's make the 5s look like 5s. Okay. 4 times negative 3 is negative 12. X to the 7th, x to the 5th is x to the 12th. Y to the 4th times y to the 5th is y to the 9th. Okay. And if I could do that, I'd be feeling pretty good about myself. Let's see. Let's talk about some of the rational expressions. Some of the radical expressions and rational exponents. Like if I had 1 over the cubed root of x, I could write that x now as a rational exponent. That's 1/3, and when I bring that up to the numerator, the exponent changes sign. Yeah. Now if I had x to the 3/5 power, the denominator is telling me that I'm taking the 5th root. Of x, and then the numerator tells me that I'm cubing it. Okay? So, there are those types of things. Now let's take a look at one where I've got 1 over the 3rd root of x cubed, and this whole thing is raised to the -1 power. Well, the cubed root and the 3rd power cancel each other out, so I've got 1 over x raised to the -1 power. To get rid of that negative exponent, I flip what's inside the parentheses, and I get just a plain old x. And that's all there is to that. Now, a parabola type problem. Let's say that showed you what y equals x squared looks like. And then let's say that we took that parabola and we moved it right and down, and that this point right here was 3, -4. And I wanted you to write the equation of this new parabola. Well, we know that y equals a times x minus h squared plus k. And well, the shape of the parabola hasn't changed. It might look like it did in my drawing, but that's just because I'm a poor artist. But a is going to equal 1. And h, of course, is the x-coordinate of the vertex, so this is x minus 3. We put that in parentheses and square it. And then it's plus k, and k is the y-coordinate, so it's plus -4. Now, if you really wanted to, you could go x minus 3 squared minus 4. Either one of those are acceptable. And I would say that if you could do this, you should be feeling pretty good about yourself. Come on in, we'll take the summative test bright and early, second hour, and I'll see you on the 12th.